Hello, everyone, and welcome to this amazing lecture on building a WebSocket group chat application using Go. And let's demo this application. If I write here, hello, and send it, on the other tab, I get this hello from that user. And then I can reply back, hey, and it is then sent back right here. Now, this course right here is a short demo course, but if you would like to go in depth after you have seen this entire course, and if you like this, but if you would like to go in depth, I have courses on Udemy where you get to build this real-time chat application using Go, and there I dive really deep. There you have one-to-one message persistence, media sharing, authentication, and real-world project structure and planning, and so on. So with that, enjoy the video, and if you like it, drop a thumbs up. Let's have a quick look at the tools that we would need to follow along this course. Now, the IDE of choice would be VS Code, and that is where we are going to write all our code. The second thing would be the Go programming language, and the third thing would be to use Postman. And Postman is what we will use at the end to test our application. And Postman is what I used in the intro video to show you chat between two tabs. Now, to get started, we need a location in our file system where we can store our project. And for that, I'm going to come to this documents in my file system, and they're in projects. And therein, I'm going to create a new folder, and I'm going to name it go underscore group dash chat. And this is a May 26. So that is the name of the folder, which shall contain my project. And then this is the folder I'm going to drag into my workspace. Now, the next thing is, within this folder, we need to initialize the project that we want to build, right? And in Go terminology, it is known as a module. So let's open up the terminal. And in the terminal, I'm going to say go space mod space init. So go create a module init, and I'm going to name it backend. That's simply the name I'm going to go with, and hit enter. So with that, our project is now created, and let's create a new file, and I'm going to name it main.go. Now in here, I'm going to create a very simple hello world application and run this just to see if the Go program is working well. Now the idea is, in a Go file, the first thing is a package declaration. So to which package does this file belong to? And because this is the first file and main.go would be our main file as the entry point of our program, this belongs to package main. The next thing would be function main, and this is the entry function. This is the function that kickstarts our application. Now, when this application runs, I want to call the FMT package, and that FMT package has a method known as println, so print line. And I want this method to print for us, hello world. And if I Control S to save it, and then I can come to this terminal and I can write go space run space dot, and then hit enter. So there we go. Hello world was printed for us, which means our program is working well. So our application has been working pretty well for us. It greets us, but greeting is not the thing we want. Rather, we want to create a Go group chat application where you and your friends could chat among yourselves. So really, in that case, greeting us is not what we want, right? So let's think about it. In our application, in our Go group chat application, what do we want? Well, let's start thinking from the inner layer. Who's going to connect to us? Users are going to connect to us, or in other words, clients are going to connect to us. So let's start by working on this client. And I'm going to create a client.go file. And we know every Go file starts with a package declaration. And because I'm going to make a very simple application, and so I'm going to keep everything under the main package. And in this file, client.go, I want to describe what a client looks like. So I'm going to create a type client struct. And in this struct, in this client struct, I'm going to describe what a client looks like. And I'm going to make it a very basic application. So at the very least, a client struct must have 3 fields. Well, if you think about it, a client should have a connection to our server. So that's the first field. The second field will be the name of the client. And the third field would be a way for the client to send some data to us. So 3 fields there. And before we proceed, let's go to Google and search for Golang Coder WebSocket, because this is the package we're going to use to handle the WebSocket. And there in package.go.dev, we get this WebSocket package from Coder. And there under the install tab, we get a command that we can use to install this package. So with that, if we go back to our project and in the terminal, if we paste that command in and hit enter, it's going to install the package. And there we go, it was installed. So with that package at hand, we can again refocus on this client. So I said the client needs 3 fields at the very least: a connection, the name, and a way to send something. So the first field, I'll name it connection, so con, and this will get a pointer to WebSocket package, and there the con type, connection type. So this is the type of WebSocket connection we want to use. The next thing is the username of the client, and this is of course type string. And third, a way to send us some data, and I'm going to name it send. I'm just going to name it send. And then this is a type of channel which just takes a slice of byte. So this is what describes a client. Now we need a function that would return us a prepared client when someone connects to us. So I'm going to create a function and I'm going to name it new client. And this function gets certain things, certain parameters. The first parameter is a connection that this function gets, which is again a pointer to that WebSocket package, and there the dot connection. And the second thing would be the username, which is a string. Now at the end, this function is going to return us that client, so a pointer to the client struct. And because this function returns us a pointer to the client struct, we're going to return a destructured pointer to the client struct. And so in here, we need to fill in the fields of the client. So the first field is that connection, and that connection is something we get from the parameter. So connection. Next, it also takes the username, and that is also something we get from the parameter. Third, we want to create the send channel right in here. So we're going to use make statement, and that make takes a channel of byte slice, and we're going to give it a buffer size of 256. So there we go. That is what a client then looks like. So we did create a client, and we also create a client, a function that initializes a client. Now, the next thing would be to create a hub. So, and what is this hub? You can think about this hub as a virtual area where multiple clients are connected and they're chatting between themselves. So we need to create a hub and then a few functions to register a client to the hub, a function to unregister the client when the client goes out, and a third function to take whatever one client is sending, so one message, whenever a client is sending us a message, take that message and send it to everyone else. All right, so those 3 things we need. So in this lecture, we're going to create that hub. I'm going to create a new file and I'll name it hub.go. And of course, this is under package main. So what does this hub look like? So let's create a type hub, which is a struct. And really, this hub has clients, right? So I'm going to name this field clients, and this is of type multiple clients, right? So for that, we will use a map where the key is pointer to those clients that we created. and bool as the value. So if this client is connected true or false, right? So a hub manages all the client, and we're using the client's pointer address, memory address as the ID or the key, and the value is true and false. So if client A is connected, true or false. If client B is connected, true or false, right? So that is what a hub is. It manages all the client. The next thing would be to create a function that creates this new hub. Whenever we turn on our server, we want to create this hub. So a new hub function, and this function is going to return us a pointer to the hub, like so. So of course, within the function, we're going to return a destructured pointer to that hub, and we need to fill in that clients. So at the beginning, when we run our server, of course, there won't be any client connected, right? So we need to create an empty map. So we're going to use the make keyword. And in this make function, we want to pass map, where the key is pointer to client, basically this, and the value are bool. So like so. This function then initializes this client struct. Now we need three functions: a register function, an unregister function, and a broadcast function. So let's get started. And all these functions, all these three functions, will be methods of this client struct. So a function, which is a method, so we make a pointer receiver of that hub, and I'm going to name it h, which is a pointer to hub. And I'll name it register. And this function, what does it register? It registers a newly incoming client. So a C, which is a pointer to the client. Okay. Now in this function, what do we do? Well, we want to access the hub. And because this function is the method of that hub struct, because we have that pointer receiver to that hub, we can access the H, so the hub. And on that hub, we want to access the clients. And then we have to set the incoming client, right? So on this hub, we want to access the C there. So the client that we're getting, please remember this hub takes a pointer to client in its map. So we access the client of the hub, and there we entered the C, and that we set it to true. So that is one thing. Now this function is ready, but if you think about it, we have one single hub, and if at the same time, if 2, 3, 5, 6 people are connecting at the same time, we wouldn't know which client to put first, which client to put second, right? So we want to make sure that we have a proper lock and unlock mechanism. You can think about it as a washroom. You go into the washroom, you lock the door, you finish yourself, you unlock the door, you come out, and then someone goes in. We need something like that. We need a lock mechanism. So we're going to use the sync package from standard library. So import sync sync. No worries, it's going to import automatically. And on this hub, we want to use that locking mechanism. So I'm going to name it mutex. And this comes from the sync package, and they're the mutex type. Okay. So before, in the register function, before we registered the client, first I want to lock the hub. So I'm going to access the hub, and on that hub, we now have a new mu. And on that mu, we can call lock. So it locks the hub. We then registered the client, and then we unlock the hub. So we access the hub.mu, and on that we do unlock. So that is then the proper function. Next, we need a unregister function. So a func, which would be a method to that hub. So h, it's a pointer to that hub. And its name is unregister. And this function again takes a C, which is a pointer to client type. And what it does is it is going to set that map at that client entry to false, right? So hub.clients accessed by the C, so the client, and set it to false. And of course, just like before we do anything, before we modify the hub, we need to lock and unlock the hub. So h.mu.lock, and after we are done, we call h.mu.unlock. So there we go. Two of our functions, register and unregister function, are now ready. Now onwards to the third function, the broadcast to all function. And the job of this function would be to take any data that is coming in from a client, take it and send it to everyone else. So how do we do it? Again, let's create a function which is a pointer receiver of that hub type. So h pointer to hub, and I'm going to name it broadcast. Now this function should take a few things. For example, it should get a message, and a message is a slice of byte. And the other thing is we want to get the pointer of the client who's sending the message. So a sender, and the sender is a client, is a single client. So within this function, what do we do? Well, if you think about it, we should make a for loop, and we should range on all the clients of the hub and send this message one by one. So we need a for loop, and we're going to give it a name of C. All right. And we're going to range on the hub, and they're the clients. Okay. And when we range over all the clients of the hub, we get each of the single client, hence I'm naming it as C. So now within this function body, what do we do? Well, the first thing is I don't want to send the data to myself. That's one thing. So I'm going to make a check if the C is not equals to sender. Okay, if the C is not me or the sender, only in that case I'm going to send. So we need to access a select statement because we are working with channels. And on that select, I want to call the case of the client, and they're the send channel. And to that send channel, I want to send in this message. And then I also have a default clause, which I'll simply keep as empty. So then that is my function for sending in a message. Now, just like before, when we broadcast one message, we should also lock and unlock this function. So I'm going to access the hub.mutex, and there I'm going to lock this hub. And when finally this function ends for a single message, I want to call differ, and I want to unlock it. So differ h.mu.unlock. So those were the three functions that we need for the hub to work. Thus far in our application, we have worked on the client and we did work on the hub. And the client simply means who's connected to our server, and hub would be the manager of all the clients. So the hub would take the messages and forward to the other clients and so on. Now, what's left is to create a function that would handle the incoming request from a user, take his request, upgrade the request to a WebSocket connection, and handle the WebSocket activities. Now, for that, I'm going to create a new file, ws.go. And of course, since we have just one package, which is package main, that is what I'm going to declare here, package main. And in this file, I'm going to create a function which I'm going to name handle ws. Now, this handle ws should get three things actually. So from a regular handler function, it needs the response writer and the request. Other than those two, we also need the hub itself. So the hub that we will later initialize in main.go. So let's give it all these three things. First is a hub, which is a pointer to the hub that we created, or we will create in main.go. We will then need w, which would be HTTP package, and they're the response writer. So with which we respond back to the client, and R, which is the original request. So pointed to HTTP, and there the request. Now, the first thing is that I want to take the incoming connection of the user with this WNR and upgrade it to a WebSocket. So for that, I'm going to access the WebSocket package, and there I have this accept method, which takes the W, it also takes the R, and some WebSocket accept options, which I do not bother about at this moment. So I'm just going to pass nil. So this then gives me a connection, a WebSocket connection, and a potential error. And first I'm going to handle this error. If error is not equals to nil, in that case I'm going to call the fmt package, or actually the log package, and there I'm going to use the print line method to print some statement, and I'm going to say accept error. So there was an error accepting, and the error is the error itself. And of course I want to return out of it, so I don't want to continue with this function for that client. But if we don't enter this if error statement, it means we have a proper connection. So now we can take this connection and we can create a new client, right? But if you remember, creating a new client requires the connection and also the username. So the idea is whenever a user is connecting to our server, we want the user, of course, the user is going to connect to us using some URL, and we want the user to put their username in the URL, and then we want to read from that URL his username. So for that, I'm going to create a username variable, and I'm going to get into the request, the original request, and there the URL, and on that I'm going to query. All right, and I'm going to query, which gets me this get method, and I'm going to query there the username field. Next, I'm going to check if this username, if it is equals to empty string. So maybe the user did not give their username. All right, and in that case, I'm going to set this username to anonymous, like so. And now we have a valid connection. We do also have a username. So all that's left is that we create a client, and I'm going to use this client variable to make this new client function, which would take the valid WebSocket connection and the username. So with the client now ready, we can then access the hub, and there we have the register function, which takes the client to register the client into the hub. And after that, I can create a simple log statement. So log.println, and I can simply say connected, and who's connected? The username. So there we go. The next thing would be some few details that we need to work. For example, read pump, and we will also have write pump. So our function is going to wait in here, and it's not going to end. It's going to stay in here stuck, waiting for incoming messages from the client. So that would be the job of this read pump. And the write pump would simply take anything that we want to send back to the client, all right? And because our functions will be blocked in here, we won't execute forward, but we want to execute when the client ends this connection. So when the client ends this connection, we want to call hub again, and on that we want to call unregister. And then to this unregister, I want to pass the client back, so we remove the client from the hub. And then I also want to call this connection WebSocket connection, which takes this close method. And in this close method, it takes a WebSocket status code and a string reason. So I'm going to add the status code using WebSocket, and I'm going to use status normal closure. And for the string, I'm simply going to pass by. And because we are closing the connection, I can also make a log statement simply by saying disconnected as opposed to connected. So disconnected username. So we created the function that would take the connection of the user and then handle all the WebSocket activities. But there I left two comments, read pump and write pump. So what are these? Now, in this function, like I said, we need a statement that would block this function from moving forward, and that would be this read pump. Now, this read pump would be a for loop where we are going to infinitely listen for whatever is incoming from the user, all right? So a for loop where we want to infinitely listen for the user as long as the connection is not closed. So we want to enter the connection, and on that connection, we have this read method. And we want to read the request and there the context. And this then would give me three fields. It would give me the incoming message type, the data, so the actual data that is incoming, and an error. So let's handle the error first. And I'm going to do if error is not equals to nil. I just want to break out of this loop. And if I break out of this loop, I'm automatically going to unregister the client and close the connection. But if I don't enter this if error statement, it means I have a proper data. So now I need to take this data and convert it into string so that as we have a message, and then we need to take this message and send it to the other clients. So let's create a message type so we know what a message should look like. We are creating a type message struct, and a message should have two fields at the very least. The username of the user who's sending, so a username which would be a string, and I'll also add some JSON tag here so I can convert this message to a JSON properly. So username, and the message itself, which would be another string. And this too gets a JSON tag, which would be named as message, like so. So now within the for loop of the read pump, because we don't have an error, we have proper data. So I want to create this message variable to which I just want to call this string function and pass the data to it, because this data is byte slice, and to make it a proper string, we pass it to the string function, which then gives us the message. So now, actually, instead of this, I'm going to use this message struct, and I'm going to already pass the username here, the username that we got, and in here we also pass the message, and there I'm going to use the string function to pass the data. So that then gives me a proper message. Now I can then take this message and pass it to the broadcast of the hub. But first, I need to convert this message into a JSON, because the hub is going to send JSON data to the front end, right? Browsers can only get JSON data using HTTP. So I need to convert it into a JSON, for which I'm going to name a JSON MSG variable, and I don't care about the error. When I use the JSON package and there the marshal method to marshal this data into a JSON, this message into a JSON. So this gives me the JSON message, and I can simply now call the hub. And on that hub, I have a broadcast, which then can take my message and the client who's to be ignored, and rest of the other clients are to be sent. And that is all for this read pump. In our last lecture, we created this read pump where the main loop would stay stuck forever, listening for incoming data. Now, in a chat application, we don't want to just listen for data. We also want a way to keep sending data whenever they're ready. Now, the job of this for loop is to listen for data, and anything that we write outside this for loop would not execute once we are within this for loop, right? Because this for loop is for listening data. So what do? Now, fortunately, Go language gives us goroutine. And for this write pump, I'm going to write a signature goroutine. So go punk, and this is the syntax of writing a goroutine, like so. And the special thing about goroutine is when Go compiles this file top to bottom, and it's going to read all of this, and it will come here. And the moment it sees a goroutine, it will not bother understanding, thinking about this goroutine. It's simply going to take everything within this function, within this goroutine function, and extract it out of this main loop and throw it into a separate Go runtime or a Go runtime scheduler, a Go routine. All right. So the benefit would be then we would execute to the next line, and we will come to this for loop. And we will stay stuck here listening for incoming request. And because this Go routine is extracted out of this main loop and it is running in a separate loop, there inside of this Go routine, we can again create a for loop where we can indefinitely keep sending the client back data whenever they're ready, if that makes sense, all right? So now, inside of this Go routine, what do we want? Well, the first thing is I want a for loop, and I will get a message here. So I'll create a message variable, and I'll get message when I would range over the client and they're the send channel. So now in here, instead of this for loop, I can use the connection that I have to write something back to the client. And this takes three things. It takes the connection, it takes the context, it takes the type of message and the data itself, and it returns an error. So for the context, I'm going to use the request and there the context. And for the message type, I'm going to use WebSocket.message text because we're just handling text messages. And for the data itself, I'm going to use the MSG that we created right in here. So then this might give me an error, a potential error, which I should handle. And if I have an error, if error is not equals to nil, I just want to break out of this for loop. Or otherwise, if there is no error, I'm sending data back to the user anyways. Now, when this Go routine ends, I want to make sure that I differ call something. So I'm going to use a differ statement here. And I want to make sure that I close the connection properly. So connection.close. And like before, this connection close takes a status code and a reason. So for the status code, I'm going to use WebSocket dot status normal connection closure. And for the string, I'm simply going to use or simply going to write closed. So there we go. This is what our write pump is, and the job of this write pump would be to send data back to the user. Now, the difficult part are already done. We have created client, we have created hub, and we also have created a handle WS function that takes an incoming request and does whatever it needs to do. All that's left is that we create a Golang server, and to that server we say, bro, you need to listen for incoming request at some particular endpoint, and whenever that endpoint is being hit, you take that connection and attach it to or pass it to that handle WS. So how do we do it? In our main function, so whenever the app starts running for the first time, I want to create the hub first of all. So I'm going to create a hub variable, which would simply call the new hub function. And that new hub function would create a hub and store it in the hub variable. The next thing is I need a multiplexer, a router for my server, which would handle all the requests. So for that, I'm going to create this hub max variable, and that would store the HTTP package and there the new serve max. And new serve max would create a multiplexer and store it in this max variable. The next thing is that we need to create our server. So I'm going to create a server variable, and this would be a destructured pointer to the HTTP package, and there the server struct. Now on the server struct, I want to set the address, which would be colon 8080, so the port on which this server should run, and it also needs a handler, or in other words, a router, or in other words, a multiplexer, which would be this max. Now, the thing is, before we run this server, so for example, server.listen and serve, before we do that, so this is what runs the server. So before we run this server, we must handle whatever endpoint we want to prepare for. So before we create this server even though, I'm going to call this max and I'm going to say handle function. So to handle something at a particular endpoint, so slash WS. So I want to listen for incoming request at this slash WS endpoint. And whenever a request comes at that slash WS endpoint, I want to start or fire a function. And to this function, I'm simply going to pass the handle WS. Now this handle WS takes the hub. It also takes the W and the R. All right. And that is the only endpoint we have. And now we create the server and we'll run the server. Now this server gives me an error which I can handle simply by using the log package and there the fatal method, right? And here I can make some print lines using the log package and there the println. And I can say server running at at colon 8080. Other than that, I can also say log.println, and I can let the user know, whoever is running this server, which endpoints are available. So WS endpoint, endpoint point, and that can be found at ws colon slash slash localhost colon 8080. All right, and slash ws. Now, if you remember, when a user is making a request, we also want the user to attach their username. So for that, I'm going to use this question mark, and I'm going to make this username equals to name, like so. And so whenever in 2 years, 3 months, whatever time you run this server, when the server is running, you get to see clearly what endpoint to hit and what URL parameters you can pass. Now it is time that we run our server and test the WebSocket activity or WebSocket capabilities and try to chat between two users. So for that, I'm going to launch a new terminal. And on this terminal, I'm going to say go space run space dot. And if I hit enter, I get to see server is running at some port. And the available endpoint would be this. So ws colon double slash localhost colon 8080 slash ws and then the query parameter. So I'm just going to grab this and I'm going to use Postman to try this out. And on Postman, I have this plus symbol, if I click this, I get to see some options of making a new request. And the request that I want to make is of type WebSocket. So this then brings me this new WebSocket request tab, and it takes the URL, which I'll pass. And the name here, I'll pass as my username, which is Boitutik. And with this, then I'm going to connect. And then I get to see that I have been connected, and in the terminal, it says connected Boitutik. Now, I'm also going to create another request. And in here, I'm going to pass the name of electric and connect. And back again at the terminal, I get to see electric is also connected. So now let's send a message from electric first. Hello? Anyone there? Send. And it says, hello, anyone there was sent. And if I go to Boitutik's tab, indeed, a message, hello, anyone there from the user electric arrived. And let's reply back. Yes, I am here. And send it back. So the message was sent, and back at the electric tab, I get to see the message is indeed here.